All right, Erin, this is the last video I'm going to give to you. This one deals with looking at some properties that logarithms have. And if you think about a logarithm as an exponent, it will make sense why these properties are what they are. So there's some equivalency things that we can talk about with logarithms. And I'm going to do it in two values. Log of 2 and log of 3. So let's talk about what log of 2 and log of 3 are. Oh, and also let's just call this properties of logarithms. Sorry about that. So when there is no little number that you see inside of a log, just like our square root doesn't have a little number, it's just assumed to be a 2. When this occurs, this number is assumed to be 10. So this logarithm is basically saying 10 to what power is equal to 2. All right, and this one's saying 10 to what power is equal to 3. And if we wanted to evaluate those, we could use our logarithm calculator. Let's get a decimal on this one. Log, I'm going to put in a 10. Not sure if this one does it without the base. Of 2. So calculate on here. It's 0.301. So that's what this log is actually representing. Now, what's interesting is that if I add these two logarithms together, so if I add log of 2 plus log of 3, so we know log of 2 is 0.301, and log of 3 we can get over here. Log of 3, we calculate on that, is 0.477, is plus 0.477. If we add these together, we get 0.778. And what's interesting is that this value is equivalent to log 6. I'm going to show you that over here. So back to the calculator. Hopefully this is not too confusing going back and forth. You see that? 0.778. So this is an interesting thing that happens with logarithms, and it kind of is because of the fact that they're exponents. Do you recall how when you learned in algebra that x squared times x cubed equals x to the 5th? Right? It's this idea that you can add the exponents. It's the same thing with logs. So if I add two logs together, it is equivalent to when you multiply these two bases. So if I wanted to find an equivalent expression to this, I could say log of 2 plus log of 3 is equal to log of 6, because 2 times 3 equals 6, because log of 2 times 3 is equal to 6. All right, so it's an interesting property that happens with logarithms. Anytime you're adding two logarithms together, you could condense them to 1 by multiplying their values, right? What they're being taken of. Is that all right? It's a similar idea with division. What would you expect to happen with division? Well, let's see. Log of 2 minus log of 3. Okay, log of 2 minus log of 3. So that should be 0.301 minus 0.477, which should be a negative 176, negative 0.176 if I did the math right in my head. So I'm wondering what a minus sign is going to act like, and this should be similar to, or be equivalent to, the division of the two values. So let's see what's going on here. I'm going to change this to log base 10 of 2/3. I'm going to hit calculate. Oh, I don't think it knew that value. 0.666666666666666. So 2/3. And what do you know? Negative 0.176, which was equivalent to what we see here. And the last property that happens is with multiplication. So if I have 2 log 3s, for instance, 2 log 3s. So this is 2 times 0.477. Oh, I need to do a little math on that. I think it's a little late for me to be doing that. Let's go back to our Google calculator. Oh, we can use Desmos. 2 times 0.477 is equal to 0.954. So this is equal to 0.954. And what happens is when you multiply, it actually acts like an exponent. And we're going to talk about why that happens. Look, if I have 2 log 3s, that's equivalent to log 3 plus log 3, right? That's 2 log 3s. And we know that when we add, we multiply these bases. So that's equal to log of 3 squared. Kind of our proof. When I have 2 times a log, it's equivalent to log of 3 squared. And let's just see if that works. 0.94 is the solution we're looking for. And if we go back to our log calculator, if I change this to log of 9 and hit calculate, notice how you're getting 0.954. So the key thing with properties is that you can condense logs and find equivalent expressions just by applying these concepts, and you can evaluate with just one log and not add them together. So just a neat little technique of working with logarithms. All right, Erin, have a good one. I'm going to send you lots of practice, and we look forward to seeing you soon.